Okay students, so let us do a problem. Okay, so here a water drop of radius, a water drop, okay, water drop of radius 1 millimeter, okay, 1 millimeter is split into 10 raised to 6 identical drops. 10 raised to 6 identical drops. Surface tension of water, okay, surface tension of water, it is given as 72 dynes per centimeter. Dynes per centimeter. Okay, so find the energy spent in this process. Find the energy spent in this process. Find the energy spent in this process. This is not answer, I am just going to start. Okay, dyne per centimeter. So here we will have to write the area. Fine. Okay, got the answer. So 72 dyne per centimeter, so we will convert into joule, not joule, Newton, then 10 raised to minus 3, 72 into 10 raised to minus 3, and this is going to be 4 pi into what is okay, fine, sorry, this is okay, this t is not required now. Okay, fine, 4 pi into what is the capital R? 1 millimeter. So 10 raised to minus 3 whole cube into what is n here? 10 raised to 6. 10 raised to 6 all raised to 1 by 3. So 10 square minus 1. So just to simplify this, how much will be getting? Simplify this, how much will be getting, children? Minus 10 to the power square. Okay, all power 2, right? Now are you getting this answer? 89.5 into 10 raised to joule. This is the final answer. Just check whether you are getting that. Clear, children? Okay. Okay, fine. Okay. Now this surface tension is property of liquid, property of any liquid. Liquids just have. Now just put the heading excess pressure. Excess pressure in a liquid. Excess pressure in a liquid drop. Actually, there a pressure from outside. There will be a pressure from outside. Then there will be pressure from inside. Pressure due to that liquid there. Correct. Other than that, there will be pressure due to surface tension also. Correct or what? Okay. So pressure, the force due to pressure from outside will be in which direction? Correct or what? The force due to pressure from outside will be in which direction? Inwards. Inwards. In which direction surface tension will be acting? That is also inwards. Correct. Pressure due to liquid. So what is happening? Force due to external pressure, that is also coming out. Due to surface tension, that is also coming out, coming in. So pressure due to external force due to external pressure, that is coming into. Surface tension, that force is also, force due to surface tension is also into. Force due to the liquid, okay, it will be acting in the outer direction. All of these pressures are acting in the same area. Correct or what? So can I write external pressure plus the pressure due to surface tension? All of them are where? Into the drop, acting in this direction. So this is external, and again I have shown this direction. All these are due to surface tension. In the outer direction, this is due to liquid pressure. Okay, so actually the direction I can show of force, since they are acting in the same surface area. Okay, all of them are acting in the same surface area. Clear or what? Clear? Okay, note it down. If you have any, if you do not know, please note it down. If you know this, leave it. Okay, now for this to stay here, see, the pressure due to external into area plus pressure due to surface tension into area, not pressure, force. Okay, pressure into area, pressure into area. This will be equal to pressure due to the liquid in the opposite direction. Okay, pressure due to liquid. Clear? Fine. So pressure due to the outside force or outside pressure, this is due to surface tension, this is due to liquid. Clear or what? Now A if we cancel, then external pressure plus surface tension is equal to the liquid pressure. So in this, which all things are happening inside the liquid drop? Which phenomenon is acting? Okay, so better what we will do, this pressure due to external, okay, pressure due to external minus, this is actually internal, yeah, this is pressure due to internal. What is the difference actually? Pressure due to surface tension, pressure due to surface tension, correct or what? The difference of pressure from inside and outside is actually pressure due to surface tension. Okay, see, we will write in this way. The internal pressure, okay, or liquid minus the external pressure, the difference is actually the pressure due to surface tension, correct or what? Okay, what is the pressure due to surface tension, children? What is pressure due to surface tension? P in minus P external. This I am writing as 2S by R. 2S by R. The pressure due to surface tension is 2S by R. If this is a liquid drop, if this is a liquid drop, okay, so there is a derivation for this actually. There is a derivation for this, but I am giving you directly. Okay, the pressure due to surface tension for a liquid drop will be 2SR. Only one more difference will come if it is a soap film or a bubble, means the only difference will come is 4S by R. Okay, just remember that. Okay, so pressure due to surface tension in liquid drop is 2S by R. Pressure due to surface tension in a soap bubble, okay, in soap bubble, if we take this 4S by R, okay, pressure due to surface tension in a liquid drop is equal to 2S by R. Clear? So this is the excess pressure. 2S by R is the excess pressure inside a liquid drop. Okay, 2S by R will be the excess pressure inside the liquid drop. So suppose if we consider a situation like this, okay, what is this? This surface is what? Concave or convex? Okay, this is concave. For this side, convex. Okay, so for this side it is concave and the other side will be convex. So this is what? So in the concave side, In the concave side, we are having excess pressure. Actually, that is the reason this is having this shape. Clear or what? On the concave side, we will be having excess pressure of 2S by R. Suppose if we take a soap bubble, okay, for this also, this side 4S by R. What is this side? Concave side. So always the concave side will have excess pressure. Remember this. Clear or what? Okay, right? Fine. So now let me summarize this. What? Just a direction means I was showing this direction, just like this side is concave. No other. Okay. There is no direction, force or pressure, nothing. Just showing that this is concave side, this side is convex side. So when we look from this side, this is convex. Nothing else. Okay. So children, right. Okay, so I am summarizing this thing. This is nothing but if we have a liquid drop, there will be inside, there will be pressure outside. Pressure inside minus pressure outside is going to be 2S by R. S is the surface tension. We take, this is liquid drop, this is soap bubble or any bubble, okay. So in this case, this is pressure inside, this is pressure outside, then Pi minus P naught will be 4S by R. Clear? So with this basics, we will get into capillary action of the this capillary action. Okay, see children, suppose if we keep a capillary tube like this, okay, capillary tube like this, this is water molecules, this is water molecules, and this is glass molecule. So this could be water or any fluid, water or mercury, anything, methyl iodide or anything. Suppose if it is, see, force of cohesion. Force of cohesion means the force between similar molecules. So suppose the force of cohesion, if this is fluid, so I am writing like the liquid molecule, the force between liquid molecule. Another side I will have force of addition. Okay, so I am writing this as force between liquid and glass, we will glass. Suppose if they are equal, then this capillary rise will not happen. There won't be any meniscus. Means this level will be same like this. Okay, so this is one case. Why to worry about this? Sometimes two possibilities are there. No, this can bend in this direction, this can bend in this way also. Those children who haven't seen this for a long time might have forgotten, right? So that is why I am saying. Okay, so this is one case. There won't be any capillary rise. So I can say, suppose if this is the direction of force of cohesion, okay, then this, suppose if I, okay, leave it, okay, so net force, everything will be in this direction, so there is no meniscus, nothing. Another possibility is we keep a capillary tube here. Suppose force of cohesion is equal to, that is force between liquid molecules. Force of cohesion is force of liquid molecules, and this side it is force of adhesion, that is force between liquid and glass molecule. Suppose if force of cohesion is greater than force of adhesion, means it will be like the net is, force of cohesion is more, force of cohesion is more. So suppose if we consider force on this side and if we consider on force on this side, if we consider both sides, we can take separately. If we take this side, what will happen is more force will be towards this bulk. So the resultant force will be in this direction. Okay, so maybe more force of cohesion is in this direction, and force of adhesion, if it is in this direction, when we take, if it is more, the resultant will be in this direction. Correct or what? Right. So now suppose if we take this line, if we draw a line like this along the tube, and okay, leave it, that we will discuss later. Okay, this one you understood. So there will be a meniscus like this. So in this case here, force of cohesion means, okay, correct, no, okay. So force of cohesion, that is the attraction between like molecules, okay, attraction between the liquid molecules are more. Okay, then what will happen, it is, this is going to be capillary fall. If we consider a tube like this, there is going to be capillary fall. Instead of rise, this will come down. Clear or what? Okay, so this is the second case. Third case, suppose if we take like this, this is the capillary tube. Suppose force of cohesion, the force between liquid molecules, and force of adhesion, the force between liquid and glass. If it is like this, that is the force between liquid and glass is more, what will happen is this will take a meniscus like this. This side also it will take the meniscus like this. So this side it will be like this side it is going to be like this. So the water surface is like which, like what, like this. This is the net force. So force of adhesion will be, cohesion will be in this direction, force of adhesion will be in this direction, so the net will be this one. So this is more, force of adhesion is more, so the net force will be in this direction. So I told you, okay, the water surface will be in such a way that its normal will be the direction of net force in the beginning. Okay, so that is what is happening here. Okay, clear? So those who do not know, please note down this. We will get into the details now. Okay, so here what will happen? I did not say this thing. Here what will happen? Capillary rise will happen. Capillary rise will happen. And here what will be the shape of the meniscus? Here it is attaching to the glass, same way here this will be attaching to the glass. Okay, same way here this is going to be different. We studying about this height, capillary rise. Okay, regarding capillary rise we will be studying. See children, shall I ask you one thing? This is concave meniscus or convex? Which side concave? Upper side is concave. So more pressure will be on which side? On the concave side. Inside the sphere pressure was more, allava. So if we make a sphere here, this side it is going to be 2s by r extra pressure. That's it. Okay, so copy this down, we will discuss further. Shall I erase this? Okay, this angle of force, the side of force of cohesion, force of adhesion, the net force, all these things are for your understanding. Just to understand that meniscus, this liquid surface, okay, its normal will be the net force, just for your understanding. Okay, now the real thing which we need to understand for solving problems. Okay, Okay, so let's see. Now I draw a straight line in this direction. Okay, this doesn't have anything to do with the net force along cohesion or adhesion or nothing like that. I am marking a line along the direction of the capillary tube. Next line I am marking along the tangent of the meniscus. So this meniscus is like this. So towards the water I marked like this. Now I measure this angle theta. So for capillary rise, so this is going to be the capillary rise. That is where I have what? Force of adhesion is greater than force of cohesion. So force of adhesion is greater than force of cohesion, or capillary rise is happening. Capillary rise is happening. So in this case I know that theta is less than what? 90 degree. Okay, the line along the tangent of the meniscus and line along the capillary tube, if I draw, I am getting an angle which is less than 90 degree. Okay, so here capillary rise is happening. Okay, fine. Now in this case, if I draw a line like this along the capillary tube, where I will be able to draw the tangent. So meniscus is now this one. So if I draw the tangent, I can draw like this. So if I measure the angle theta, this theta is greater than 90 degrees. So in this case, force of adhesion is less than force of cohesion. Okay, what is happening? Theta is greater than 90 degree. I will be getting capillary fold. Okay, so I will be getting suppose if okay, so in this case what? Force of adhesion is equal to force of cohesion. So what will be theta? So if I draw this line and if I draw along the tangent like this, I am getting what? I am getting 90 degree. Okay, I am getting 90 degree. So in this case, force of adhesion is equal to force of cohesion. Okay, clear. So normally in the case of water, pure water, when pure water will be taken, what is happening? I am getting theta is equal to 90 degree. Okay, theta is equal to 90 degree. In this case, suppose force of adhesion is greater than force of cohesion. One example, suppose if we take methyl iodide, so theta will be somewhere around 29 degree. Theta will be somewhere around 29 degree. Clear? Okay. Suppose in this case, so here force of cohesion, liquid molecule is very strong. The best example which we can give here, it is mercury. So angle is around 137 degree. Angle is around 137 degree. Okay, mercury, very strong cohesion force, correct? Okay, so suppose if we keep some other fluid, it will be, maybe it will be like this. Okay, the spherical shape will not be that beautiful. Okay, if we keep some other fluid, suppose if we keep mercury, okay, so this will be making very beautiful sphere, mercury, because the force of cohesion is that strong. Done? Clear? Suppose if I consider a point like this, if I consider another point, this is x I am considering, if I am considering x, okay, so this point is x and this point is y, okay, this point is y. What is the pressure at y? Going to be P naught. What is the pressure here? P naught. Pressure inside. How much less than P naught? Minus 2s by r. Point, I could say that the pressure is P naught to, suppose if this height, okay, this height is h, this height is h, what will be the pressure at x? Pressure at x will be P naught minus 2s by r plus h. Pressure at x will be equal to pressure at y alva. Correct dane? So without paining you much, okay, to prove this, P0 will be equal to what? Okay, Py is equal to Px. Py is equal to P naught, Px is equal to P naught minus 2s by r plus h rho g. This r is the radius of this capillary tube, dane? Abdiya? Liquid drop alliya, liquid drop. What is the pressure inside? 2s by r. Excess pressure is 2s by r. So this r is the radius of edo or capillary tube. Radius of this liquid cord. So this round where we are getting here, zooming this, so this capital R is the radius of the meniscus, clear or what? In the P naught cancel idumilla. So 2s by r is equal to h rho g dane. This h is the capillary rise. Okay, so can we write h is equal to what? 2s divided by r rho g. Correct or what? So this is formula for the capillary rise. Capillary rise. So surface tension, radius of the meniscus, density of the liquid, and G. Okay. Okay, done. See children, look at this. Now this is the capillary tube. This is the capillary tube. Suppose if this is the meniscus we are getting here, if I extend this, I will be getting the meniscus. This R is what is present here. Correct or what? Radius of meniscus. Radius of the meniscus. So this is what is the small r? Radius of the capillary tube. So if we put cos theta, this is going to be adjacent side by hypotenuse. So can I write r by r? So this r is equal to what? R by cos theta. So I can modify the same equation. In which way I can modify this into capillary rise height is equal to 2s cos theta by r rho g. So in the place of r, I will be substituting small r by cos theta. Correct? Okay. Shall I raise this? Fine. So when you study, when you revise today, you can do all this. You can go through the required derivations and all. But when you study for the exam, what you should be in your mind? This formula. Then what is this small r? Radius of the capillary tube. Capital R is the radius of the meniscus. Okay, why it is rising up, why it is falling down, what is the relation between this theta, all these things should be there. Okay children, done? Okay, now we will do one question. Okay, so pure water capillary rise is 7.5 centimeter, surface tension is 0.075 Newton per meter. So theta is equal to 0. Okay, and the density is equal to 10 raised to 3 kilogram per meter cube. G is equal to 10. What is the radius of the tube? Radius of the capillary tube. So H is equal to 2s cos theta divided by r rho g. R is equal to 2s cos theta divided by h rho g. Theta is given as 0. Okay, so that will become 1. So that will become 1. So 2 into the surface tension is 0.075 divided by the capillary rise is 7.5 into 10 raised to minus 2 into density is given as 10 raised to 3 into 10. Into 10 raised to minus 4. Okay, 2 into 10 raised to minus 4 meter, or we can say 0.2 millimeter. 0.2 millimeter. So that is the kind of capillary tube, very small tube of very small radius. Okay, so this is going to be 0.2 millimeter. Okay, next question. Okay, children. So capillary rise means always the pressure will be 2s by r less than the atmospheric pressure. When you come down, that pressure will be further h rho g will be less. This derivation, this understanding was important. That is why I have shown like that. Clear or what? Okay, that was important. P naught minus 2s by r, P naught minus 2s by r minus h rho g. Understood or what? Right. Plus h rho g. Plus h rho g. Clear. So another question. So capillary tube R is equal to 0.5 meter. The radius of the capillary tube is 0.5 meter. Then we are using water, so its surface tension is given as 0.075 Newton per meter. Question is, find the difference in pressure. Find the difference in pressure between a point which is meter below the surface of capillary, okay, and atmospheric pressure. Okay, so the question is what is the difference in pressure? Find the difference in pressure between a point which is 5 centimeter below the surface of capillary and atmospheric. how much will be the difference between the atmospheric pressure and the pressure at the point 5 centimeter below the capillary? So that is a question. Okay, take down these options. 0. Okay, 100 Newton per meter square, 200 Newton per meter square, 300 Newton per meter square, done, 350 Newton per meter square. So children who are watching online, you just do on your own. Okay. Okay, students who are watching online, I believe you will be sitting with the pen and paper. So when I am giving problem to the students here, just assume that, understand that you are also sitting in the classroom, then do on your own. Correct? Then verify the answer here. And if you wish, you can make a visit 1 or 2 days, try to attend offline classes, get the feel, then you can go back also, your wish. Once in a while you should talk to them also, right? Okay children, how to do? So this will be the, okay, so this will be the capillary rise. So at this point P0, here it is going to be this level P0 minus 2s by r. So that is pressure. Okay, we need to find 5 centimeter below, right? 5 centimeter below, what is this pressure? So this will be what? P0 plus P0 minus 2s by r plus h rho g. So that is the pressure here. What they are asking? Pressure difference. Pressure difference between what and what? Between atmospheric pressure minus P at this point. Okay, or we can say between atmospheric pressure and P at this point, correct or what? So this P0 minus pressure at that point is P0 minus 2s by r plus h rho g. This is what? Correct or what? Okay, so take it inside. This is going to be P0 will be cancelled off. This is going to be 2s by r plus minus h rho g will come. So this is the difference in the pressure between atmospheric pressure and that point. Okay, now you substitute the values. 2 into what is the surface tension? 0.075 divide by what is this children? This radius of the meniscus. So what they have given? Radius of the capillary tube. So radius of the capillary tube, how we will find? R by cos theta. So what is R? Sorry, how this comes? This is R meniscus, this is the small r, this is theta. Okay, so cos theta is equal to what? R by r. So R is equal to R cos theta. Small r is equal to what? R cos theta. So what they, small r is given. So capital R is equal to small r divided by cos theta. What is this small r?
0.5.
0.5. So whether they have given cos theta? They haven't given cos theta. So when they haven't given cos theta, means that angle will be very small. Angle will be very small. When the angle is very small, in the case of sin theta, what we used to write? In the case of sin theta, will be equal to theta used to write. In the case of tan theta, if this is very small, what we used to write? Theta. If you are getting cos theta, if it is very small, this will be equal to 1. Okay, so you can take it as 1. Done? So okay, fine. So take it as 1. Cos theta, you can take it as 1. So 2s divided by whatever we are getting. Okay, so r you can put it directly in this situation, 0.5 minus, what is the height? 5 into 10 raised to minus 2 into rho is 10 raised to 3 into g is 10. Simplify this, children. What you are getting? So this 10 raised to 3, 10 raised to minus 2, if we cancel, we will be getting 10. So how much is this? This is going to be 500. And what we are getting here? This is actually 4 layer. Hmm? 0.3. Okay. Okay. Clear, children? So here this is actually millimeter. Okay. If you put millimeter, nothing to worry. This will become 10 raised to minus 3. 10 raised to minus 3. So if we put it on the top, we can put 10 raised to 3. So this will be how much then? 300 minus 500. 300 minus 500. So the pressure will be, we can mark like 200 Newton per meter square. Correct or what? So this one you can mark. Clear? Okay. You take question number 5 in the handout. Question number 5. Question number 5 in the handout. With increase in temperature, the viscosity of gas and liquid are compared there. Correct? Gas and liquid are compared there. So with the increase in temperature, what will happen to the viscosity of liquid? Decreases or what? Viscosity of liquid will decrease with the temperature. So decreases, liquid decreases, option B and D are there. So just by knowing the viscosity of gas, what will happen, then only we will be able to answer that. So see this equation. This is the viscosity of gas. Eta by 3 root 2 sigma 3 kT by pi m. So this viscosity is directly proportional to root of temperature. Okay, so if temperature increases, what will happen? Viscosity of gas will increase. So now you will be asking doubts on this. Clear? No, you need not ask this again, right? Clear? Okay, so another important thing is, have you heard about Reynolds number? Reynolds number. So Reynolds number is nothing but a number to mention how much streamline, how much turbulent water is. Suppose if the Reynolds number is, means that is also not that accurate, but somewhere around just a somewhat approximate value. If that number is somewhere around 1000, okay, that will be very turbulent. Okay, if it is less than 500, then that is going to be streamline. Okay, so somewhere if you see that, you need not worry. Reynolds number means only that much. Okay, again, if you see somewhere any decent question, you can ask me. So here, suppose if it is less than 1000, okay, you mark that also number. Reynolds number. Okay, the type of flow pattern. Okay, this denotes the type of flow pattern, streamline or turbulent. Streamline or turbulent is decided by Reynolds number. Streamline or turbulent, whether this streamline or turbulent, we can decide by Reynolds number. So Reynolds number denoted as RE. Okay, RE, this is equal to inertial force by viscous force. Inertial force divided by viscous force. RE is equal to inertial force divided by viscous force. Okay. Done. So here if it is less than 1000, then this is streamline. Less than 1000, streamline. Greater than 2000, turbulent. Greater than 2000, it is turbulent. Okay, if it is 1000, streamline. If it is 2000, greater than 2000, it is turbulent. Clear or what? Okay, fine. Less than 1000, it is streamline. Greater than 2000, turbulent. Between 1000 and 2000, we stay unsteady. Between 1000 and 2000, we say it is unsteady. Okay, children, so if the velocity of this flow, if it changes, we are increasing the velocity of flow. Say for example, if we are increasing the velocity of flow, at certain point what will happen? This streamline or laminar flow will become turbulent. So that velocity is called the critical speed, critical velocity. Okay, that is enough. Okay, critical velocity or critical speed. What is that critical velocity? What is that critical speed? What is its formula? All these things are not required. Okay, children? Fine. So, fluid mechanics is done. Over. Shall we revise the concept and formula once in 5 minutes? A quick recap. Can you do on your own? Okay. So, right from the beginning, fluid statics. Okay, we will go back. We will start from the what? Today's topic, surface tension. What is surface tension? Force by L, F by L, force per unit length. Then what is surface energy? Surface tension into change in area. Change in surface energy is surface tension into change in area. Correct? Simply a surface energy is nothing but surface tension into area. Surface tension into area. Correct? Okay. So surface tension, surface energy should be less. Okay, it is just like a potential energy. These things will try to reduce the energy, so it will try to make less area. While making less area, what will happen? The area will be reduced. Okay, so in the case of spherical drop, big drop converting into small drop. Okay, just tell me all the four formulae. Slowly. First formula, 4 pi t into small n small r square minus r square. Second formula, 4 pi t into capital R square into n raised to 1 by 3 minus 1. Third formula, 4 pi t into R square into capital R divided by small r minus 1. Fourth formula, 4 pi r cube into t into 1 by small r minus 1 by capital R. Good. Then what is the energy required to make a liquid drop? 4 pi r square into t. If you need to blow and make a soap bubble, what is the formula? 8 pi r square into t. Why that 8 is coming, children? 2 surface area. Already it is a bubble. If you want to make it into a better radius, a bigger one, then what? 8 pi t into r1 square minus r2 square. If it is a soap bubble, if it is a liquid drop, 4 pi t into r square minus r square plus. Then what we studied? Excess pressure. Excess pressure inside a liquid drop is what? 2s by r. Excess pressure inside a soap bubble is what? Good, superb. Then capillary action. If the force of adhesion is equal to force of cohesion, will there be any capillary rise? Will there be any capillary fall? It will be steady. Correct? Pure water. Okay. If the force of cohesion is greater than force of adhesion, example, mercury, what will happen? Fall or rise? Fall will happen. What will be the angle between the tangent on the surface of the liquid and the line towards the capillary tube? Will be what? Greater than 90 degree. Mercury 137 degree. Correct? Perfect. force of addition is more than force of cohesion, what will happen? Capillary rise. What will be the angle between the line towards capillary and tangent will be less than 90 degree. Example, methyl iodide 29 degree. Will there be capillary rise? Yes. What will be that height? 2s by r rho g. What r? Capital R or small r? Capital R. What is that r? Radius of the meniscus. Superb, excellent, amazing. Then what is the other formula? 2s cos theta by small r rho g. So small r is nothing but the radius of the capillary tube. Radius of the capillary tube. If you want to find the pressure below a point, what we will be doing? Outside the meniscus, what is the pressure? P naught. Just inside the meniscus, what is the pressure? P naught by 2s by r. Then just h meter down, what is the pressure? P naught minus 2s by r plus h rho g. Okay, so thank you so much. Then yesterday's everything you are remembering? Okay, down vertical h rho g, horizontal 0, accelerating upwards g plus a, h rho g plus a. If it is coming down, h rho g minus a. Left or right, rho l a. Tan theta is equal to h divided by l. L by g is equal to L by g is equal to g by a. H by L is equal to a by g. Clear? Then law of flotation. Law of flotation. What is the upthrust? Upthrust is equal to V in rho L G. What is the mass? V rho into G. Correct? If it is moving down at the floor, apparent weight is equal to mg minus u. Mg minus u. If it is on the top, either half or full or a part of it outside, a part of it inside, mg will be equal to upthrust. Apparent weight is equal to what? Mg minus upthrust. If it is fully completely floating, there won't be, it is floating, weightless. Okay, 0. Done. What else we have studied there? Anything? Barometer, h rho g. Manometer, how much is the gas? Same point we take h rho g. U tube, how much it is moving? Take the 2 points. Pressure A is equal to pressure B. Take the things very carefully. Take the things very carefully. Done. Fluid dynamics. Fluid dynamics. Equation of continuity. A1 V1 is equal to A2 V2. What is Bernoulli's theorem? Pressure energy plus kinetic energy plus potential energy is equal to constant. Okay, so P plus half rho V square plus rho GH is equal to constant. What is pressure head? Kinetic head. Potential energy head. The dimensional formula will be L. Dimensional formula will be L. Just we will be dividing with rho G. We will be dividing with rho G. Then Venturi meter, rate of flow. A1 A2 into root of 2GH divided by A1 square minus A2 square. If the area of one side is very big, the other one is very small, what is the velocity of Flex? Root 2GH. What is the equation of range? Root of 4 into H minus H into H. Where we will be getting maximum range at height h by 2. From where we will be measuring the height? From bottom or top? From top. From top we will be measuring that small h. Done. How much time is required for emptying the tank? Capital A by small a into 2h by g. 2h by g. Done. Over. That's about dynamics. Everything is covered, no? Viscosity. Viscosity. So what is viscosity? On the top, viscosity, viscous force is nothing but minus of eta A dV by dz. dV by dz is velocity gradient. velocity on the top minus velocity on the bottom between by divide by this distance. Then Stokes law, 6 pi eta RV, a sphere moving inside the water, 6 pi eta RV. So force is there, 6 pi eta RV. So when this force is there, velocity will be increasing. So always velocity inside the water based on Stokes theorem will not be constant. That velocity will be changing, force also will be changing, acceleration also will be changing. We won't be able to use V is equal to U plus AT, those kind of equations. Okay, so that is always changing. Next, after that, terminal velocity. If a raindrop is coming down, downward mg, upward upthrust, another upward motion is viscous force. So 6 pi eta RV plus V im rho L G is equal to what? Mg. So since this is increasing, mg force is there, this is increasing, velocity will be increasing. As the velocity will be increasing, this Fv will be increasing. Finally a state will come, Fv plus U will be equal to mg. So when this happens, velocity will be constant, lock. Okay, lock happens, that is called terminal velocity. What is its formula? 2 by 9 R S square G divided by eta, viscosity. Okay, that is about terminal velocity. Done? No? Everything. Are you comfortable? So try to solve maximum problems. Okay, the problems level can be anything if you check. So the handout is given, so try to solve it. Remind me, I will be sending the keys. You do on your own and try to find and try to discuss with your friends. Finally, if you are not getting, you can give that numbers to Cynthia ma'am. If she is on leave, you can give to Joshua sir also. Okay, so whichever questions, and atoms also I have given. You will be getting the assignments on AC also. So all of them please solve, and wherever you have doubt, maximum. Okay, after trying yourself, after discussing with your friends, try on your own maximum. Finally, if you are not getting, you can send to me. I will be solving that and showing to you.